Hi, my name is Brian, and welcome to part 3 of sketching the derivative. Part 2, we did something very similar to what I'm going to do in part 3, but I tried to improve the applet a little bit so that it could help you determine the slopes without guessing. So in the black, I have my regular f of x, which I can choose up here. So I chose 2 cosine plus x minus sine squared, basically so that I can have a function that has some strange slopes. And then in the blue here, I have the derivative. So what I'm going to do is I want to try to find the slopes here. Now you would try to guess this slope, and I thought that was kind of difficult. So if you choose the option show tangents, then that means at all of these corresponding points now, I can actually adjust so that the tangent, or basically the tangent line at that point, will give me the correct slope. So now I can, as you can see, you can adjust the point. So obviously, at a y value, if this is the derivative, then this is a y value of 4, which means the slope of this line down here is 4. Now, clearly, that's not the slope at that point right here. So I'm going to adjust it, and I'm going to say the slope is about right there. So that's a y value of, it looks like 1. And then you would do that for all the other points. So that's about good there. So again, you just adjust the slopes. So we're getting a little bit steeper as we move along this function. Now we're starting to flatten out a little bit. So you can see how I'm actually doing this so it goes flush with the graph right here. So it has the same slope. Let's do Q. All right, so we're moving down. Now the slope is negative. Slope is still, and actually it's pretty close to 0. Now the slope at this point, it actually looks like it's exactly the same. Okay, and then you just keep going up. Okay, and finally, last one. That looks about right. So now what you can do at this point is remove f of x and remove all the tangents, and then you can show the derivative and see how close we actually are. We are actually pretty close. I'm actually very pleased with how close I am to the derivative. All right, so if I adjust this, maybe I use x squared. All right, we're pretty good with x squared. We've dealt with that before. Um, So there's x squared right there. What I'm going to do is show the tangents, and let's do it again. That one's actually kind of tricky to see. Actually, we can't see that one. All right, let's go to M. Let's adjust the scale here. Okay. All right, so it looks like, all right, we're pretty good there. And then, okay, so I'm just playing around with the slopes, trying to match them up. All right, I think I'm doing pretty good. Now, if you, at this point, if you've done derivatives plenty of times, you probably know that this is a parabola, this is x squared, so the derivative should be 2x. So my graph, or my derivative, should look like the line 2x, which that pretty much is 2x. So if we hide the tangents, and then we hide the function, if I show the derivative, it should look pretty much like that. Yeah, okay, so we're pretty good. All right. So I will put a link at the in the description of this video to this page, and so you can come in and you can change the function around. So here's x, let's say x cubed. Oh, I'm not showing the function. All right, so there's x cubed. So you can play around with this. Hopefully this helps you practice sketching a derivative, and I believe that showing the tangents will help you with determining slopes.